Hello. Today we are going to begin Lesson 11. Lesson 11's focus is now taking these proportional relationships that we know and writing equations for those. It's going to be fairly simple once you get the hang of it because the equations will always look the same, and that's what we're going to talk about today. So the EQ for today is how can I use and analyze equations that represent proportional relationships. So once we write these equations, we're going to be able to use them to find information about this proportional relationship in lots of different ways. So in Lesson 10, you learned about proportional relationships and how they are represented on a graph. In this lesson, you'll learn about equations that represent proportional relationships. So we learned about graphs and tables in Lesson 10. We did a little bit of review yesterday. This table is showing a proportional relationship. It says that the number of cars is 3, 5, 6, or 8, and the number of people we can take depends on the number of cars we have. And we can take 18, 30, 36, or 48 people. Now, that makes my number of cars the x value and my number of people the y value, because remember the x is the independent variable and the y is the dependent variable. So the number of people depends on how many cars we have. We can notice here there's a pattern. For 3 cars to carry 18 people, we multiply that by 6. Same thing happens with 5 cars. If I multiply that by 6, I can carry 30 people. With 6 cars, 6 times 6 is 36. And with 8 cars, 8 times 6 is 48. So that tells us very important information about this proportional relationship. So let's go down to the questions. Find the ratio of the number of people to the number of roller coaster cars for each set of data in the table. Remember, those ratios are fractions. So I'm going to say 18 people to 3 cars. And I'm going to leave a little bit of space because we're going to simplify that. 30 people to 5 cars, 36 people to 6 cars, and 48 people to 8 cars. Now, when I simplify each of these, now remember you can use your calculator to help you with that. I'm going to use division, just like if we're finding a unit rate. So 18 divided by 3 gives me 6. If I do that for each of these, I will get 6. Notice they're all equivalent. And they're all equivalent to that number that we can multiply the number of cars by each time. So it says, are the ratios of the number of people to the number of roller coaster cars in a proportional relationship? The answer is yes. Because they are all equivalent, we know it's a proportional relationship. How many people can ride in one car? The answer is 6. What is the constant of proportionality for the data in the table? Also the unit rate. What is the unit rate for the data in the table? Also 6. For each car, we have 6 people. So if we want to find the number of people that can ride in a roller coaster with 10 cars, I'm going to take the 10 cars and I'm going to multiply it by 6. And that gives me 60 people that can ride. So, if I want to write an equation to represent the number of people, so what does the number of people equal that can ride the roller coaster with X cars? It's basically what we did right here. The number of people is equal to 6 times the number of cars. Okay, now I want to add this to our notes because this is really important. So on that page where you set up your EQ, we're going to rewrite this example just a little bit. So we know that X is going to stand for the number of cars, and that Y is going to stand for the number of people. I also want to just sketch a graph for this. Now, it's not going to be a very big graph, but I do want to show you that it is a proportional relationship in that way, and we can figure out how to gather the unit rate from the graph as well. So I'm going to go up by, I need to go up to 50. Actually, 45 is fine. So I'm going to go by 5s. 5, 10, 15, 20, 25, 30, 35, 40. And I'm going to go over to 8. Okay, this is the number of cars. And this is the number of people. Okay, so again, 1 car carried 6 people. 2 cars, 12. 3 cars, 18. 424, 530, 636, 742, and 848. So when I draw this line, it's straight and it goes through the origin. Now remember, this unit rate is this first point here, 1, 6. So we found the unit rate because there were 6 people in 1 car. So we can find it here, or like we did on our worksheet, we found it because we did the ratios. So we divided y by x to find the constant of proportionality. Okay, and they call this value k. Don't ask me why they picked the variable k, but they call it k. So, our equation will always look like y equals k times x. In this case, it's y equals 6x. But it will always have that same form. Y equals the unit rate times the x variable.